In this tutorial, we will review the available communication links on the controller. There are multiple ways to connect to the controller for communication. It's important that you understand each of them so you can use them all correctly. The first available communication type is Ethernet. There are 4 isolated RJ45 Ethernet ports. The Ethernet connections can be used for multiple purposes with the controller, including control monitoring, trending, and data log collection, control configuration of Ethernet IP addresses, general communications such as Modbus, manage configuration data and tunables with Control Assistant, and 505 remote view connection. Connecting to the Ethernet ports is as simple as plugging an RJ45 Ethernet cable into an available Ethernet port on the back right side of the unit. The second available communication type is CAN. 4 isolated CAN ports are available for general communications, as well as simplex or redundant distributed control. Compatible devices include LinkNet HT nodes, DVP valve products, and the 2 Woodward power management devices, MFR300 and LS5. To wire to the controller's CAN connections, Woodward recommends the Belden YR58684 Communications CAN cable. This is a smaller and flexible 22-gauge low-capacitance cable suitable for tight routing in industrial environments. For robust communications performance, the CAN cabling needs to minimize the exposed non-shielded cable section that occurs at terminal blocks. The exposed length of CAN wiring must be limited to less than 3.8 centimeters or 1.5 inches from the end of the shield to the terminal block. If multiple connections need to be made, Woodward recommends daisy chain connections. Any drop cable connection of a device to the trunk line should be as short as possible and much less than 6 meters. It is recommended to design the network trunk to be less than 100 meters with a maximum cumulative drop length of less than 39 meters. For 1 megabit per second communication, each drop cable must be as short as possible and definitely less than 1 meter. Wiring of the CAN port should be as follows. Wire the black cable to pin 1. This is the CAN signal ground. Wire the blue cable to pin 2. This is the CAN low signal. Wire the shield to pin 3. Wire the white cable to pin 4. This is the CAN high signal. Pin 5 is left empty. A 120 ohm resistor must be used as a termination resistor at the end of each trunk line. This resistor is wired with one end in pin 2 and the other in pin 4 of the connector. The third available communication type is the serial port. An isolated RS-232 or RS-485 serial port is available for customer use. The serial connections have the following specifications. A shielded cable is required when using this port. Maximum distance for the RS-232 is 15 meters or 50 feet. Maximum distance for the RS-485 is 1,220 meters or 4,000 feet. RS-485 networks require termination at both ends with approximately 90 ohm to 120 ohm impedance that matches the characteristic impedance of the cable used. The same cable used for CAN connections is recommended for serial connections. Serial connections should be wired according to the chart on the back of the controller. For RS-232, transmit and receive signals wired to pins 1 and 2 of the connector, respectively. Signal common or ground wired to pin 3. Shield wire wired to pin 4. RS-485 connections should be wired as follows. Signal common or ground wired to pin 3. Shield wired to pin 4. Positive and negative signals wired to pins 5 and 8, respectively. And 2 jumpers, one wired between pins 8 and 7, and the other between pins 5 and 6, connect the internal 120 ohm termination resistor. There should be a termination resistor on each end of the RS485 line. You now know the basics for wiring the available communication links. Please be sure to view the other tutorials for more information.